Well, hey again, everybody. This is Bob here to show off my new solar power system that I just put together recently. Actually, it's not up and running yet. I'm still waiting on a few more parts to come in. But anyways, to start off with, these are the two batteries I have for right now. Hopefully, I'll expand them later on. But two 12-volt, 190 amp hour CAT batteries, industrial batteries, in series for a 24-volt system. And over here is the star of the system, my new Solimba 4 kW inverter with a 12 kW surge, which is pretty impressive as far as I'm concerned. And in another video, I will be putting this to the test and see how good it works under a load. So stay tuned for that. I also added some remote switch terminals on this because it doesn't come with it, and my system is running by automation mostly, so I needed that, and so I put those on there. That's what those are for. Let's see what else we got here. Well, I put a battery desulfator on the system too, and there's my battery minder 24-volt desulfator just humming away. And over here I have a shunt which feeds a meter that goes into my bedroom that shows me what kind of amperage the system is drawing and what the voltage of the batteries are, so I can keep constant monitor on that when I'm in the house. And because it's winter time, these batteries need to stay warm, so I've got a heating pad underneath it, and to control that and the temperature and all that is another one of those gadgets. You see a lot of those in my video. Anyways, that keeps the batteries at about 70 degrees for me during the winter time, so that they charge better and discharge better. And they're right next to it. It's not on, but that's the voltmeter that comes off the inverter. It just tells me what the voltage is coming out of the inverter. And then I have my MPPT solar charger, which happens to be an EPEVER 80 amp model. And it's not a bad unit. I'm not happy with not being able to adjust certain parameters on it. And for that reason, I decided I'm going to set this off to the side and use it for a backup. And I got a new Victron, and amazingly, as I was making this video, my Victron just came in, and here she is. And she's a beauty. She's a beauty. Seems to be very well made. The casing on it I thought was going to be plastic, but it's actually metal. So I can't wait to get that hooked up. And another thing I've got is a kilowatt meter to tell me just exactly how much energy production I've done. And you probably noticed that the wiring in here is rather sloppy, and there's a reason for that. This is just put together as a test right now, and this whole system is going to be moved sometime in the near future. So this is just rudimentarily put together just to test everything out and make sure everything works like it's supposed to. Now, some of the neat things about this thing is the automation. Now, since I've got a small battery bank, I don't want to overtax the batteries and be able to kill the inverter when the clouds are in the sky. So I put another one of these sensors that I love using, and took the thermocoupler that normally comes with it and replaced it with a photoresistor. So this thing registers the amount of sunlight, and when the sun goes behind a cloud and the inverter's on, it'll kill the inverter to save the batteries. And then, of course, when the sun comes back out, then it'll turn it back on again. Another thing I got here is a timer. Now, what this does is this will automatically turn my system on at a certain time of the day and turn it back off again. And our power company has a structure where 3 hours during the day, which it happens to be 6 in the morning to 9 a.m. during the winter, and it's different hours during the summer. But anyways, they charge an outrageous fee for use of electricity. So this timer here comes on at 6 o'clock in the morning and turns back off at 9 o'clock. Unless the sun's out, then it just keeps on going. And then right there is my contactor, which all this remote control stuff feeds this contactor and turns it on and off to send power to the house. And then from here, goes over to the house. To my homemade relay system. And basically what this does is this just interrupts power on certain circuits in the house that are most commonly used in there, and diverts it to the inverter when the inverter is running. One thing I should tell you all is if you plan on copying something like this, don't mess around with any rinky-dink relays. You're messing with house power, you want to use something substantial. These relays here I got in here are 30 amp double pole level throw breakers, so they should handle house loads pretty decently, I hope. Anyways, that's about all I got to show you all today. Thanks for watching, and if you have any comments or questions, just post them down below and I'll get to them whenever I can. And appreciate you watching. Catch you later.